and I want to describe what we're doing here. So I'm going to go back to the unit circle. So the unit circle is going to go like so. I think that I could, let me try something real quick. I think that I can add a grid somehow. Text note, duplicate. No, I don't. Choose from templates. Oh, here we go. So let me try a line grid. Maybe no. Let me try a graph. Okay. So with this graph, we have, let's just say that we go over a certain distance here. We go over a certain distance, and we would call this the x. So it's this length that is the x. Okay. And let's say we go up to a certain point like so, and this is going to be called y. So it's the y that possesses this kind of link. Now, if we want to know the distance from the origin, so you got to imagine this point right here moved from the origin and it traversed this line and then it walked up this way. So imagine a city block. You know, this is your house, this is your best friend's house. You need to go down to the corner and then make a left and then go up here. So we want to know the distance from your house as bird's eye, well, just over a straight line. We want to know that distance, and that's r. So r is equal to the square of r is equal to x squared plus y squared. This is Pythagoras' theorem. So Pythagorean theorem. All right. So we could just say, if we're going to solve for r, we need to do the square root of x squared plus y squared. So when I write that the radius, I may not have enough room here. When I write that the radius in centimeters and meters equals to SQRT and then power of A2 times, no, it's not A2, it's B2 of B2. And this second number is to the power in which you want it to be raised. So I'll do the same thing here, power of C2 squared. And then we close that. This is the same thing mathematically or symbolically written, square root of x squared plus y squared. Now I could say the square root of the square root of b squared, b2 squared plus c2 squared. Okay, so this is Pythagoras' theorem. This is where we're going to stop on that theory portion. And we're going to use that in our discussion. So you can see we have this equation. So I'm just going to go ahead and minimize that or make it smaller, and we don't have to have it this big. So hopefully you